ऑलराईट, सो आपण 7 नंबरच्या सेक्शनमध्ये येऊ. कोलॅब शीटमध्ये 6वा सेट्सचा होता जो आपण ओपन ठेवला आहे. 7वा फंक्शन्स. ठीक आहे. सो व्हॉट इज अ फंक्शन? ॲज द नेम सेज, it is something that has a specific function. It has a specific purpose. So इथे आपल्याला दिसतंय की hello has a specific purpose which is to print this. So एखादी फंक्शनॅलिटी, एखादं फीचर आपल्याला जेव्हा रिपीटेडली लागतं, that's when we use function. So this is the simplistic function. The definition is you write def space and give any name, brackets, colon, and then whatever that function is. And then when we call the function, we directly write that function name and follow with the brackets. Now this function does not have any arguments, so it's a blank function. It always prints hello. So let's call the function twice. Okay, I have not called this, so let me first call this. Okay, alright, now we are taking one step further and we are saying that we want to have a function which prints the name of the user. So here the function name hello is followed by a keyword, an argument, keyword argument pair in a way, which is name. It's a placeholder, and we are saying that the function is whatever is being passed to the function, print it with the word hello. So it is a variable. Technically whatever you are passing to the function name, function definition is a variable. So this is a variable, and you are using f string with the curly bracket. So if I pass hello 12, it will print hello 12. And here we can see what is the hello. It's a function. Now we are defining another function called add this. We have two variables, first and second, and then we are just adding it. So some more functions. Hello underscore u is the function definition, and then one argument which is name, and then hello u, hello students. So whatever we want to return, we always write in return. So whatever the function, the scope returns. So the way it works is, let's say we have this function, and this is our code. So this function can be written in any file of your project, anywhere else, for example. And then this is your function. Name is input. Input is like take user's data, and then you are calling this function. So the function call, like where the Python executes step by step, one step at a time. So it reads this, then it reads this hi function, and then it says okay, hi, we have to pass this name, and then the cursor goes to here, it calls this function, and when the return statement is got, it comes back to the original point from where it was called and inserts that thing over here. So whatever is written over here, message, will be inside this print statement. So here it is asking for something, so I am saying enter the name AI Leela and enter. So hi AI Leela. It is just printing it as it is. We have left the space over here and then done the addition of this. Now we are writing c equal to a plus b, return c. Another example, add a comma b. Here we are taking two inputs from user. So input A and input B. So let's say input is 6, input B is 8, and it is printing 14. Now we have used one more interesting thing like this, which is called typecasting. So what it does is whatever you write in input is technically considered as a string, but we want to do mathematical addition, so we are converting that string into int. But if I type a, then it cannot convert it into integer. So if I say a equal to a, then it gives me, you can invalid literal for int a with a base 10. This is its way of saying that it cannot convert it to the number. But if I type whatever else, Even if I type 5.0, I don't know whether it will be error. It is an error because 5.0 is a float. You are trying to convert that float, which is considered as a string, but that string, which is a float, you are trying to convert into int. It cannot do that. So, and interestingly, if I write str over here and even here str, then it will consider both of them as strings. And if I write 1 and here if I write 2, then it will consider as string and give me 1 2 1 2, which is next to each other because it doesn't understand that it's an integer. Anyway, so that was typecasting. Here we have a simple interest function. So now we can see that, okay, so maybe in the banking applications, calculating interest is a common functionality. So whatever is the common functionality, you put it into the function so that you don't have to write it again and again. And here we have this principal plus time plus rate of interest, and then we are calculating simple interest and we are printing it. So principal is 100, rate of interest is 8, and let's say in the 2 years, so 16. Now for readability, you can also do something like this. So we have this function called find distance. It takes speed and time, and then we know that distance equal to speed into time. So while calling it, we can also pass speed equal to 10 and time equal to 3, and it will print, and it will take this 10 as speed. So the another way was also like in the standard way we would do it like this: find distance 10 comma 3. But when there are more arguments over here, then you may be confused like which is what. So it's very specific, and when you are writing like this, even if the order is wrong, it is fine. Okay, if the order is wrong, it is fine. But if I do 10 3 and then 3 10, it is not right. But if I do time equal to 3, then this time will automatically be allocated to this time. If speed is this, then it will go to this. So usually it's a good practice to have this, especially when there are 3 or more arguments that you have to pass to the function. So that's about function. As and when we do more programs, we'll see, we'll find more utility of function. Right now this is enough to understand. Then let's go to the if-else statement. So for the 8th collab, fairly straightforward. I'll disconnect this once, 1 second. Is there terminate option? Okay, if else is fairly straightforward. A equal to 33, B equal to 200, if space, you have this condition, any condition, and then colon. Colon is your start of the block, and then as we saw in the for, we have to, it's called indentation, we have to leave some space. So B is greater than A, fine. Here if B is, now after if, you have to have the indentation, you have to leave space, otherwise it doesn't understand. So it says that expected an indented block after if. So you have to leave a space, 2 spaces. Or otherwise in 1 line also it's fine. So if the output is only 1 line, then you can directly write it in the same line. But if the output is not output, if the condition that you want to have in the if it is 2 lines, then you have to leave the blocks. If it is single 1 line, you can directly write it like this as well. It's a shortcut. Okay, then here what are we doing? We are saying that input a number to check, and we are typecasting it into integer. So I say 12, and then if 12 mod 2, so remainder will be 0. It is an even number. So yes, it's an even number. Here we are doing few more things. Again, if and else. So this was simply if. We might want else case as well, so we can write it like this: if and then else. So age is, let's say, 50. You are ineligible to vote. Okay. if else. Now we can have multiple else conditions. So if you have multiple else condition, you don't use else, you use elif, else if. So it's elif, elif, and finally you have else. Now less than, greater than is easier to understand. If it is equal to, you check it with double equal to. So this, it's as good as checking that is x equal to 1. So while x equal to 1 is assignment, x double equal to is checking whether the left side and the right side are same or not. Check whether the inputted number is 30, 40 or 50. So here we are just checking. So let's say 34. You entered a random number other than 30, 40. So it came to this last block. So it checks one by one and finally it came over here. We can have nested if. So you, as an indentation, you can see if x is greater than 10, it will come here, and inside it, it will have if else condition. So you just have to work it out. It's fairly easy. If x is greater than 10, then it will come over here. This is a shortcut. We already saw that if a greater than b, colon, and then you, if it's a one statement, one sentence, you can write it in the same line. And the same way, if you want to do if else, you can also do like this. So print a, if a greater than b, else print b. So if else is like this. Before if you have one condition, and after else you have second condition. And these are just shortcuts. As we do more and more coding, these things will be, more and more things will be opened up like this, but it has the same functionality. Then for loop we have already done. Let's just have a quick check again. So here we are defining a list. We are running a for loop through the list for course in courses. Now that's the standard nomenclature, that if you have courses defined to the list, and we should use plural when we are defining a list, because list is supposed to be multiple items. So if you are using plural, then you use the singular version of that. Ki courses hai, then you take course of it. That's just a normal good naming standards. It makes the code easier to understand as well. Or I can have like users equal to, let's say Manas, comma, let's say Daksh, comma Durgesh. So then I would say for user in users. So it's fairly easy, and for even for AI, like more and more we'll use AI. So even for AI, if you have the proper names like this, the code errors are less and less. So that's just the nomenclature. Okay. Now here there is a spelling mistake. So okay, but I have to do fruits. Okay. Tuple also you can do for loop. In the dictionary also we are doing for loop. We have seen that already. In the string also we are doing for loop. So for I in text, print I. Range is like 0, 1, 2, 3, 4. And if you say range 3 to 8, it means 3, 4, 5, 6, 7. Enumerate we saw, like for every element give the index of it as well. We can break the for statement anytime. So let's say if, here we are looping it, but we are saying that if you find BSC, break it. So we have the for loop, we are printing each element, and if the element is a certain item, don't go after that, just stop there itself. So you found BSC, it first printed it and then it broke. So if you want to stop your for loop, you can use break, and then you generally stop the for loop based on some condition. So that's why you have to use if in that case. Continue is not very much used. Even break is not commonly used in the coding assignments in general. With the continue, you can stop the current iteration and continue with the next. So we are skipping the one and then going to the next. So we are saying that if course equal to BSc, continue. So it just skipped the BSc part and then again ran this. So it did not print this. the function came over here, continue, and then instead of going here, it directly went again to the for loop. So we are skipping it. More examples. Okay, enter your name, and then for every print character. Okay, so let's say Manas. Square root. We wrote a function. Okay, square. Sorry, we are writing a function to square. Alright, fairly self-explanatory. Rest of the things are. Here we have the nested loop for each x in adjective, and for each y in fruits, print xy. So for red, do these three: red apple, red banana, red cherry. Then for big, again do these three. So this is a nested for loop. Again, nested for loop will be useful in doing matrix multiplication later on. Here we have two for loops for range, so same way. Patterns using asterisk. So enter number of rows. So let's say I say 4 rows. So for 4, for I in 0 to 4. Okay, again, so the logic you can work it out. Then we have, what do we have? Print the numbers pyramid. Okay, so number of rows, let's say 6. Okay, so we are just doing nested for loops for more thinking exercises over here. How to check length of a list if there was no length function. Okay, so with for we are doing the length. So let's say, okay, so if there is no length function, I want to check how many elements are in num. So I am saying, okay, for each item in nums, count, increase the count by 1, but define count equal to 0 first, and then whatever is the count, it is the length of that list. Just different ways of using for loop. I'll move next to the while loop. While loop is again fairly simple. X equal to 1, while x is less than 5. So till then, as the name says, while this is true, continue doing that. So while x is less than 5, print x, and we are increasing x by 1. So x will be 2, 2 is less than 5, it will come here. When x is equal to 4, 4 is less than 5, it will increase x, it will be 5, and x is, then that condition is false, so it will not go in the print loop. So it's only till the 4th, 1, 2, 3, 4. Okay. For loop is the most common one, while loop is a bit lesser. While true is an infinite loop. So if you want to run something infinitely, then you say while true. But if you are running while infinitely, then the server may get hanged. So you have to be very careful while using while true. You have to use break somewhere. So you are saying, okay, while true, keep inputting name, and when it says stop, you say stop. Okay, so okay, so stop. Okay, but we are, so this is not case sensitive, so we have to do stop specifically, and then it stopped. It did not ask me anything. When you encounter the letter T, stop. So what are we doing here? Beautiful. So while I is less than length of string, this is str1. If it's equal to T, we are incrementing, and we are just printing each element, and then when you find T, if you find T, you break. And here we are just printing example. Alright. Again, fairly straightforward. Then we have classes and object. Okay, so that's an important concept. So what is a class? Class is a common concept in all programming languages, especially object-oriented programming languages. So we'll just learn by example. So here we are defining something like this. Class C is small. Now some of the words are defined by Python, which we cannot use. So I cannot use, list equal to something. So if I say list equal to a, it should not work technically. Print, it's a bad practice if I'm using list, because list is stored by Python for some specific purposes. If I say while equal to 1 and print while, it is definitely giving me error, because while is, I cannot use it as a keyword or variable or anything. List, it is allowing me, but it is still risky, so I should not do that. So same way, the class is a fixed variable, fixed keyword, not variable, fixed keyword by Python. So we say class and then we write some name employee, and in that we have this name and age. We are defining two variables. These are called attributes in this concept, and here we are saying emp equal to employee, and then bracket start end, and then type employee. So what is happening here is we have created a variable. This variable is of data type employee. Employee data type is not given by Python, like string data type or integer float. It is not given by Python. We created that data type. We created that data type with this function called, with this keyword called class. So it's a data type which is created by us, and that data type has two attributes, we are saying, name and age. And then when I do type emp, I see this main is their default way of saying that, that is the class. This is the class name. Ignore the main is output, it represents the current file. So we are not using any file, but this is how it gives us for any human defined classes. So if I print this now, so let's run this. So we have this, and then after that we are writing the attributes, so which is name and age. So name and age, by default we are saying employee. If there is an employee, his name has to be John, his age has to be 26. We are already defining it. So here let's improve our class. So class has employee. Now ideally class name has a capital letter. It's a camel case is what is preferred generally. So first letter has to be capital in the class name. So we are saying that it's a attribute, and in the class you have definition as well. So we are saying that employee has a function. The function is hello. It always calls to itself. So any function has to have self parameter, and then we are saying print hello, and if we do emp.hello, we get this hello. Now we improve it slightly. This is more, this is much better example. This is how ideal standard class is written. So we have class employee. This underscore init is something which gets called by itself always when you create an object. So let's say this emp is an object of class employee. So what we are saying is with init, whenever any object is created, you always assign an attribute name and pass whatever is passed, pass that value to the attribute. So it will be clear from here. So we are saying emp1 equal to employee John and 26. So when Python reads this line, it goes to init. Self means this emp1. So it is saying John1, John is name. So it is saying for emp1, give name equal to John, give age equal to 26. And when Python calls this line, it says that for emp2, which is self, give name as Jane and give age as this past value is 24. So emp1 details. Now, and third thing is we are writing a function details. The details, again, the function takes its own self. We are saying that employee name and age, and the way we are passing self.name. So self.name means emp1.name and emp1.age, automatically it will pass. So when we are saying emp1.details, if we call it, we will get John. We will print this line and this line first. Employee name and age. So let's just do print dash dash dash. Okay. So with this one line, it printed this. Now if you see, let's say we had Yeah. One second. Okay, let
Sir,
me
do we
just.
have to write
Do we have to what?
uh, init? Instead of init, can we write something else, or it has to
No,
be
it has to
underscore
be
init?
init. It has to be init. Init is like constructor in the programming sense that whatever is init is automatically written. It automatically assigned to that variable. Now this also works technically, but here we are doing we are hard coding the value. But if this employee needs, if this class has some attributes which are user passed, like name and age is passed by the user, then we have to use init. If you are hard coded data, you can do like this, where everything will be, name Sana and age 26. And ignore the syntax, just understand this, because it's so common that everywhere it will be the same thing. So we just have to understand what is happening conceptually. Now one thing which I was trying to say is, if I do code and we are trying length, so if I say help list, and if I print this, we saw that this list has this count, which is a function. So what happened is, list is also a class, and in that class it has also this function. So and same way we have this employee, and in employee we created our own function. Let me just see, if I do help employee, does it do anything? Yes, so it has actually created. So when we created employee class, if we type help employee, it actually gives us, okay, initialize the self, and then details is the function that we have defined. We haven't written any information, so that's why information is not coming over here. But we actually created, we have the help statement by default when we define this class. Okay. Um, so the literal definition, if we want to see in the Python documentation, what it says is, classes provide a means of bundling data and functionality together. Bundling data and functionality. So let's say data is the attribute and functionality is the functions together. And we generally want to bundle this only when there is a similar type of thing happening. Like employee is a similar type of thing, or humans, fruits, they are similar type of thing which has multiple different properties. And instance is the object is the instance of that, like the example of that. So let's say we have this student class. We are saying self dot name equal to name. This is fairly always the same. It is like init self and one variable, sorry, one keyword, and then self dot xyz equal to xyz. We have this intro function and change name function. We have two functions. In intro we are only doing print, and in change name we are actually changing this. Now for all students, let's say a class has 60 students, we can have 60 objects. John equal to student xyz, and then John dot intro. Okay, and then again print John dot name, and then we'll get and then John change name. So if you just work it out, what happens? First we initialize John equal to student John name. So init happened. When we wrote this, init directly got triggered, and it said that John's name attribute should have a value of John. This this John is this self, and this value is this value which was passed. Then we are saying, okay, call this intro function on John. So in intro, John variable got passed. This variable got passed to this self, and it says print, hi, I am self.name, and then that self.name was here John. So hi, I am John. Then we are saying change name. So in the change name we passed what name to be written. Okay, so it called this function. This function got this new name, and then it changed the name. It assigned a new name. The name, this name is the one that was created, the past one. And then again we are doing John.intro, and then we got the new one. Let's do rectangle. So rectangle is a class, and we are doing area of it. So we define length and width and then area. So in area we are saying what is the length, what is the width, just print it out and then return the actual multiplication of it. So if we say rectangle 5 comma 2, we are saying dot area, if we are calling, it says length 5 width 2 and then 10 is the area of it. Another example, dog. So dog has a breed, it has age, it has colors. These are attributes. So an employee can have attribute of ID, joining date. A username has an attribute, a user has an attribute of password, username, XYZ. So I'll show you for AI Leela just for a quick demo. So let's say if I go to models and if I go to user table, now this is a class. Here you can see it's a live production website that we have. And in that class you can see these are attributes that I have ID, user, I have email which is an attribute, I have the username which is an attribute. So these are all attributes. So same way a dog can have an attribute of breed, age and color. And then since user passes the data, we are assigning the values to that attributes. So whenever you want to assign anything, you have this block as the same block everywhere. And for details we have this as we want. We are creating an instance dog1 and here we have to pass it in the same sequence. So let's say husky is breed, 5 goes to the age, blank goes to the color, and then dog1 dot details is this. Alright, so that was classes. As and when you use more and more things will be clear. But it's good to, so far so good for classes. I think this is enough knowledge for now needed. And lastly, I'll again quickly touch base on the packages. So Python, while it has list, it has string, it has these different predefined items, there are other libraries that people have created. So here we are saying import math. So it means that you import math library and somebody has written this math library. And if I just go to pip install math, this package is actually in Python. We are just importing it. This one is separate that I am showing you, but it is. Let's also find if we can find math over here. Okay, so the default ones are not in this page, so we'll come back to it later. Okay, so we imported math. So math is like a package, a module actually, a module that was already given by Python but not in our code currently. Now when we do import math, there are many things like this. So there is a math, there is data type, date time, there is requests. There are few extra functionalities which Python has created but not installed by default, not in your own project by default, so that you don't clutter your own code or projects, but common enough where third-party applications are not needed. So this is like in between. So we are importing math, and then math has its own function. So if you do help math, we get like math has radians, remainder, sine, signage, square root, etc. So we'll just see how to use this. There could be like thousands of such libraries, so we don't want to go through all of them. So we are saying math dot square root, then the output is 2. From math, import sqrt, then we can only use sqrt. So sqrt is a function inside math. Now how do we find out what else is inside math? So we can just do from math import, and if I do control space, okay, it doesn't give me, so probably I'll have to ask ChatGPT, or here also we can find. So here we have sqrt. We did it from help math. From help math we got that. All right, then log10 is 2. Math.log10 is the function, and then for 100, which is 10 square, so 2 square root, okay, pi. Date module is more commonly used. Math was just for example. So date time is really useful. So if I do from date time import date, and date dot today, it prints today's date. And there are many things that we can play around with date time. So let's say today equal to date dot today. So today is another function. Then today, inside today we can have day, month and year. From date time import date time, print date time dot now, it will print today's current date time. And if you want in specific format, so let's say if I want year, month and date, so if you want date and month, then this is date and month. So there are many things like that. Now if I want to explore into this, I'll just do, I'll take a screenshot of this and maybe to the Gemini, give me some date time implementations to play around. And screenshot, I'll upload screenshot of that. Okay, so it gave me a few more experiments to try, and then you can try this and see what is happening. As we move to our capstone project, this will be more important because you see, like a user signing up from US versus a user signing up from India, their browser is sending different date, and we have to handle it properly. In the database, we want to store in the same maybe GMT or UTC date time, which is Greenwich zeroth time. We are at 5:30 hours ahead of GMT. So a lot of things need to be handled. So at that point of time, these things will come more handy. But right now, what we are trying to understand is Python has extra features, extra packages, which we can use from this import, from date time import date, or directly by import math, and many other libraries are like that. So this sums up our 12 chapter basic foundation for Python. As we discussed, you have to complete all of them, at least run, and then from each chapter take something, then take a couple of things, and in your VS Code, in the engine room or in some other file, have something. So you can probably write a class, inside class you try to do a for loop, you try to do something. You can come up with your own problem statement or ask ChatGPT to give you some small problems. You just have to exhibit different things that you have learned in these 12 chapters. Okay. So yes, that's it for now. In the next session, we'll see API handling using GET and POST requests. And that's it. Thank you.